All right. Good afternoon, everyone. Welcome to today's lesson set for EMAth on a wonderful Saturday afternoon with me, Teacher Jason, over here. Some ground rules again: just be patient and understanding, observe gracious and respectful behavior, and lastly, ask good and relevant questions, which I believe you guys should have known. Now, let's get to the lesson proper. So, what are we learning today? So, you realize more or less everything is a little bit of a recap, except the main thing we are going to learn here is this thing called matrix multiplication. Last lesson, you realize there's something called scalar multiplication you have recap. Then you may think, teacher, what is the difference between scalar multiplication and matrix multiplication? In fact, this is a whole bulk of the lesson today, and you may wonder why is there a need for that? Let's get down to it with a little recap over here. Now, let's recap. We know in this case a matrix, it's going to be actually expressed in what we call a rectangular array of numbers. Okay, and then what we call the numbers inside, we call them the elements. Okay, first thing to take note when we talk about matrix multiplication, the order is actually very important. In this case, the order of the matrix is the number of rows. Okay, a pointer over here, this says times, but in English, we actually says it is by. So the number of rows by the number of columns. Okay, so in this case, for this example, can anybody tell me what will be the order of this particular matrix over here? Take your time, write it down, think about it. Okay, there's gonna be 2 rows and 3 columns. So what will be the order of this particular matrix over here? Okay, does anybody want to give it a try? Okay, so there's 2 rows, 3 columns, and so what's the order? All right, very good. So you realize over here 2 rows and 3 columns. That's where I have my order to be 2 by 3. Do not write 6. The order is not 6. In fact, we write it to be 2 by 3. All right, that's the order we write it in. Okay, now knowing the order, we actually need to understand something very important. Before we go on to the concept of matrix multiplication, there is a particular rule that we need to take note of. All right, okay, we can only multiply 2 matrices over here. Okay, take note. Okay, only multiply 2 matrices if, in this case, the number of columns in the first matrix is equals to the number of rows in the second matrix. Now, to identify what does it mean by the first, in this case over here, if you look in terms of the blue color box over here, okay, the first matrix I'm referring to is actually the one in green. And the second matrix I'm referring to is the one in yellow. So the order has to be A, B. So in this case, you realize what I meant is the number of columns. Columns, if you recall, it is on the right-hand side of when I write the order. In this case, this is the order of the matrix. Number of columns on the first matrix is equals to the number of rows in the second matrix. And therefore, what will be the order of the matrix? It's going to be, you realize, these 2 numbers here, and then bring together to write the particular order, in this case, M times P. Now, look at this particular note over here. Matrix of AB is not equals to matrix of BA. Now, why is that so? Okay, now, this will actually be shown more detail when we go through the work example, but how does matrix multiplication comes about? So that's why we take note in matrix multiplication and look at the video and take note to listen to this particular explanation when the video is gone through. All right, so let's go towards the video time. So when we talk about matrix multiplication, the first thing we take note is this. Okay, the rows and columns have to be the same. So you realize the first one, first order, the green one has 2 rows, 3 columns. Okay, if you take note, okay, in terms of the green, again, 2 rows, 3 columns. That's the first thing to take note. Okay, and then we realize the second one has 3 rows and 2 columns if you follow the particular notion of multiplying. Now, how will the new order come about? You realize it's going to be this way if you follow my explanation just now. Because the rows and columns are the same. Okay, take note, the rows, the columns in the first matrix is the same as the rows in the second matrix. Okay, so how do we take note? They are the same. I mean, in this case, the number. Since they are the same, what happens? Okay, what will be the new matrix? This is what we have went through in the conditions just now. Is that equals to 2 by 2. So that's where the numbers comes about. If you see the color coding, one in the light green, one in the blue color. Now, in this case, if you realize, how do I get 2 by 2? That's where the matrix multiplication comes in each of the entries. So realize, look at the highlighting over here. If I want to get the first row, first column of the new matrix, what I need to do, I need to multiply the first row and first column of the second matrix, row and column. All right, and how would I do that? By multiplying throughout. The multiplication is as such. So 2 and 4 will come down together, plus 3 and 1. So the top and the top, middle and middle, and the last entry and the bottom will come together, and we perform the multiplication 11. And this particular entry will go up to form the first row, first column. Again, let's do it the same thing for the second one. In this case, the second one will be the first row, second column. Okay, I want the first row, second column. So first row, second column. So I multiply by the first row of the first matrix, because the first row of the first matrix, and the column of the second matrix. Multiply them throughout. 2 by minus 3. Again, following the entries, top with top, middle with middle, bottom with bottom. Okay, multiply them throughout, you're going to get the entries 1. And following the same analogy again, this will go to second row. Okay, try to get the process down. This should be a little clearer by then. Again, second row, first column. It's going to go over here. Okay, sorry for that. It's going to go over here. Second row, first column. As you have seen already, top with the top, middle with the middle, as the numbers have gone here already. Following up further, you're going to have the bottom with the bottom. Summing them, you're going to have the entries minus 8. And lastly, you realize minus 2 and 0 for second row, second column. So the entries will repeat as such. Okay, now following the entries over here for n minus 1, that's where you have 2. So these are the calculations. Okay, so remember, if you want the first row, first column, you multiply by the first row of the first matrix and the first column of the second matrix. And this is how it comes about. And in general, suppose, let's say, how do we express them in general? How do we matrix multiply? So if I have A and B, in this case, you realize, can I multiply them? Yes, I can, because it's 2 by 2, 2 by 2. So the columns in the first matrix is the same as the rows in the second matrix. And if I multiply them, okay, does anybody want to give it a try? What will be the entry I get if I multiply first row and the first column of the matrix? What will I get in this case of the entry over here? Because I want first row, first column. What is the expression I will get in the green color box over there? Come, write it down. I'll give you some time, think about it, write it down. What is the entry that I will get? Alright, that's actually correct, Ziying. Anybody else wants to try? You are getting it. Awesome. Very good, Denise. Anybody else still wants to try? Give it a shot. Alright, this is going to help you. So again, we will follow top to the top, bottom to the bottom. If there's middle, you have to be careful of what middles you'll be multiplying. In this case, it's a little bit like distributing. Okay, something very familiar to the distributive law I've learned in Sec 1, but a little bit different in matrices now. And it has to be in a certain order, okay, which in this case, certain manner, sorry for that, I don't want you to get confused with the word order, based on the size of the matrix over here. Okay, but good job, Zing and Denise. In this case, A will go with W first entry, top with top, and then B, Y bottom and bottom. Following this analogy, first row, second column. Okay, suppose I were to do it with red and in this case yellow over here. Red and yellow, you're gonna get AX plus BZ. And again, if I were to color code green with blue, okay, follow my color coding, guys, you will be able to hear it nicely. Okay, you are going to get, in this case, CW plus DY. Okay, last one to actually get your understanding, what will I get for this particular entry over here? Give it a shot, you can write down your responses. What will I get in that particular entry over here? Okay, give it some time. I'll give you some time to think about it. Okay, what is the entry that you will get following this particular multiplication? Very good, Zing. Perfect over there. Anybody else wants to give it a shot? Okay, that is correct. That means you are getting it already. Very good. Okay, Denise, I think there's a little typo at the other side. Okay, CX is correct. What is the other term? Yes. Okay, I think it's a typo. Just take note. That's correct. Anybody else still wants to give it a shot? Before I write down the answer for you, in this case, I mentioned CX is correct plus DZ. Okay, so just get the multiplication. In this case, this is 2 by 2. But what happens if there's different matrices involved? So that's why you realize this whole lesson over here is to get you to familiarize yourself with the matrix multiplication when you face different matrix multiplied together. In this case, work example 1, again, listen to the explanation as I go through. Okay, now, this is actually a 1 by 2 matrix. So write down the order to make sure what you get, 1 by 2 and 2 by 1. When we matrix multiply, what is the order that we will get? In order not to confuse, first things first, what is the final order of the matrix you will get? Okay, so one thing to take note, we can write it down. Write down the entry. What is the final order? Very good, Denise, that's actually correct. Does anybody else wants to try? I have a 1 by 2. I have a 2 by 1. What is the final order of the matrix I can get over here? Okay. In fact, you will realize already. Thank you for the answer, Denise. And for the rest, very good, Zing. Perfect over there. So realize, if you got it already, you realize I'm going to get a 1 by 1. So it's going to look like a number. Okay. 1 by 1. So how we multiply? Take note, in this case, it's going to be blue color. Sorry, not blue. I'll just color code the same way. Green and blue. So top with top, bottom with bottom. Okay, so that's where I'm going to have. Let me extend this bracket a little. Sorry for that. Wrong one. Okay, let me just extend a little. So that's where you're going to have minus 2 times minus 3 plus 1 times 7. Okay, again, because it's 1 times 1, so you're going to get 6 plus 7, which in this case is 13. Okay, 1 times 1, you may ask, do I need to include the brackets? Answer is, you have to leave your final answer as such, even though it's 1 times 1. The bracket itself tells us it's a matrix containing only one number. It might not really make sense over here, but you have to take note, you have to include that particular brackets to tell us that it is a matrix. A matrix of what? 1 by 1. Okay, very important over here. All right, I hope you guys are getting it. You guys are doing good. Okay, so from here, as you guys know the notion. Okay, sorry for that. Let's have another example before I move on. So, let's have another thing. So, suppose I switch the order, you realize right now. If you look at work example 1, my matrix are the same. My matrices I use are the same. -2, 1, -3, 7. Suppose I switch the order. Okay, you realize the note I say AB is not equals to BA. I just switch the order. What is the order of the matrix that I will get? This is 2 by 1. This is 1 by 2. What is the order of the matrix that I will get when I multiply these two matrices together? In this case, 2 by 1. In this case, 1 by 2. Right now, responses very good, Zing. Anybody else wants to try? Very good, Denise. Anybody else wants to give it a shot? What is the order of the matrix that I will get? Okay, simple to remember. I think you guys are getting it. There's a 1 here. There's a 1 here. So what we do, it's going to be 3 and 1. You're going to get a 2 by 2 matrix. So the way we multiply, in this case, each of the entries will be as such. It's going to be as such. This way. So it's going to be 2 by 2. So each of the entries, again, there's only one entry, so top with top in this case. So top with the top. Next one again, -3 with 1. Following up with 7 and -2. And lastly, following up with 7 and 1. So this gives me 6 -3 -14, 7. So you realize, 1, the notion is knowing how to check the multiplication. And 2, you all should have realized that from work example 1 and 2, we calculated that one of them gives me a 1 by 1, one of them gives me a 2 by 2. So therefore, for the matrix multiplications that we have done, we can actually conclude, therefore, the note that I mentioned, that if I multiply this way, it is not the same. I repeat, not the same where I do it this way. So this is one very important thing when we talk about matrix. It's very different from numbers. If we multiply this way, suppose in this case we have mentioned where A is in green. Sorry, this is not green. Sorry for that. A is in green. And B is in blue. They are giving you entirely different matrices. So this is one very important thing to take note. Okay, and this concept will be further broken down when we go through further examples. But for now, bubble question number 1. Okay, 1 minute long. Try it yourself. Try it in your own timing first. Let's see whether you can answer in 1 minute, in 3, 2, 1. Let's go. All right, very good. All right, that's good over here. Take note. Okay, what is the matrix they are going to get? Okay, be very, very careful. Do not get them mixed up, but most of you are doing good. I would say you're doing very well. If you guys are doing great, you guys are doing awesome over here. So just take note on the manipulation that you get. Okay, we have about, let me see, we have about 25 seconds more. Last 10 seconds. 5, 4, 3. All right. Perfect over here. Almost a perfect response, just that some of you may have gotten the columns and rows mixed up. So take note, what will we get? So evaluating this matrix at birth. Take note, this is going to be a 2, this matrix, and this matrix over here. So take note, in this case, this is going to give me a 2 by 1. This is 1 by 2. So we are going to get a 2 by 2 matrix. How do we solve it? Again, -1, 3. Recommendation, try to write it in this manner, whereby the top aligns and then the bottom aligns as well. Okay, so I believe I no need to highlight because you got the notion. So it's going to be -1 times 1. And the other one is going to be -1 times 2. After that, 3 times 1 and 3 times 2. This is then going to be -1, -2, 3, and 6. Right? This is what you're going to get, and therefore answer is number 1. Right? So don't get our columns and rows mixed up to get to the matrix multiplication. All right, now let's bring it up a notch. Suppose what happens in this case when you have to do a little bit of manipulation, similar to the animation that we showed just now. So moving on to the third work example, So then again, let me test you. I'm going to actually test you this way for this whole lesson because it's very important. The left hand side is a 2 by 2. Right hand side is a 2 by 1. In this case, what will be the order of the matrix at the end? Write down your responses. What will be the order of the matrix that you get at the end? 2, 0, 3, 1, and minus 1, 4. What will be the order of the matrix? Very good, Swing. Very good, Denise. Perfect over here. Good job. What about the rest? Does anybody else want to give it a try? Okay. All right, very good. Seems like you all have gotten it. So you realize how this works. Take note. We know the left hand side is 2 by 2. Right hand side is 2 by 1. So our goal, we know, is to get a 2 by 1 matrix over here. I'm going to write it extended because I'm going to show you how it comes about, how all the elements comes about. Now, 2 by 1. Now, I want the first row, because 2 by 1 means there are 2 rows. I want the first row, first column. So how do I do it? First row, sorry for that. First row, first column. Again, top to top, bottom to bottom in this particular case. So that's where I have 2 by minus 1 plus 0 by 4. Following the other way, easier to see with the yellow color highlighter. In this case, it's going to be 3 by minus 1 into 1 by 4. This will then simplify to give me minus 2 and in this case 1. Right? So I hope you get the understanding as we go by. Very good seeing. That's actually the working I'm looking out for. Yes, but yes, I get what you mean. And in this case, take note of the working there. You guys are doing good. You guys are doing very, very well. Now, in this case, what happens if I actually switch them? So if I were to actually do this, I have a 2 by 1 matrix and 2 by 2. What is the order of the resulting matrix? Some of you are following to the trap. Are you sure it's 2 by 2, Zi? Do I have an order? Let's take note. Remember? Let's take note. Yes, do I have an order even? So you realize, remember, that's why I emphasized at the first lesson, at the first part before I went through the animation. What is the criteria of matrix multiplication? In this case, these two are different. And to answer the next question, can I actually switch them? Take note. We call this, Denise, AB is not equals to BA. So I cannot switch them around because the answers I get will be different. Right? So therefore, in this case, take note over here. The next part will actually tell us why this does not work. In this case, time to listen again, as such. So how will I actually sort of let you guys explain how we get the answer? So suppose, let's say, I don't believe you, teacher. I don't believe you. I want to try to multiply, even though the rows and columns are not the same. I don't believe you. I want to try. So what I do? Write them first. Let me just write it down. Explain to you. Okay. So remember, when we matrix multiply, I multiply the row with the column. Now this is very, very important because this actually tells us why we cannot matrix multiply if the columns at the first matrix is not the same as the rows in the second matrix. Now when we matrix multiply, take note, we have to have all the numbers multiplied together. In this case, first part, okay, no issues. I can do this. -1 times 2. But then you realize, if you row-wise, this number is multiplied to this number. But is there another number where I can actually multiply to 3? Can I have a number that I multiply to 3? It's not possible. There is no number row-wise in my first matrix over here If I do it row-wise, there's only one number that I can multiply here. But for this number, it's lonely. There's no number to multiply to. So is there a number? A very big question mark over here. Answer is there is no such number. No number over here. So, therefore, for this answer, there is no solution. So, be very careful again. This is to reiterate the fact that over here, when we talk about matrix multiplication, we have to understand this fact over here, which I will erase this part and bring it down here to let you guys know there is no solutions to be found. And that's why we cannot say A, B equals to B. So take note, this is very, very important. Right? Very, very important. Alright, so I hope you got the understanding. And with that, let's bring it down to the next work example, shall we? Oh no, not one next work example. To the bubble question. So right now, this is to actually test where the answer will be. And in fact, what is the particular answer that we get? Alright, launching the bubble launcher in 3, 2, 1. Let's go. Okay, take note, look very carefully. Is there an answer first? Once there is an answer, or if there is an answer, what is my answer? Alright, write down answers. Yes, some of you are falling into the trap. Take note. What is my answer over here? Yes, I see some of you are slowly bringing into the trap here. Huh? What is my answer here? Take note. Remember what I always do first before I matrix multiply. Do I go straight on into the matrix multiplication straight away? Or do I write down the orders of my matrix first? Okay, last 5 seconds. 3. Alright. Okay, so this is where we ask. There's a mix. There are two famous options that are chosen, and luckily one of them is the correct one. But let's take note. Some of y'all were clicking option number 4. They realize, there is a solution. Why so? Now, always remember first things first. Matrix multiplication. What's the first thing that should come to mind? Columns on the first matrix should be equals to the rows at the second matrix. Are they the same? Sorry, it's not 2 by 1. Are they the same? If they are, what is the final order? If they are the same, what is the final order? Put them together, 1 by 2. That's right, Ziying, perfect over there. So what can we do? Now that we know there is a certain order to multiply, how do we make sense of this multiplication? Write it up. 1, 5, and we write it 1, 8, 3, 2. I mean negative 1, 8, 3, 2. What we do, remember, when we do it row and column, and we multiply them, we realize that it tells us 1 row, 2 columns. We take note, okay, 1 I can multiply with minus 1. Plus, very good, Ziying, perfect over here. 5 multiplied with 8. Does the multiplication make sense? Yes, it does. Each of the elements are getting multiplied. We repeat for the second one. In this case, with yellow, with green. 1, in this case, with 3, plus 5, in this case, with 2. Perfect over here. Thank you for helping me, Ziying. Okay. In fact, the working you've written here assures me that you are all understanding what I've written. And for the rest as well, I hope you all understand what I've written down here. So from there, solving it, it's going to be 1 by 2. Sorry, I think I might have written wrongly. It's 1 by 2. Sorry for that. It's first row, second column. First row, second column. So it's going to be this way. Let me rewrite it. Okay, don't worry about it, guys. Let me rewrite it. Okay, so it's going to be first row, first column. That's also a learning pointer here. First row, first column. And the way we multiply, first row, second column. And this, we get our answers 39, 13 in row wise. Because this means number of rows, this means number of columns, and henceforth our answer is this side over here. Alright, so I hope through this understanding, you may realize the significance of how matrix multiplication works. Okay? Okay, I hope you guys are getting it over here as such. Because if you guys get it, what happens? We are now going to branch off to more matrices with higher order, which may be a little bit more tedious, and you have to understand the entries over here, even more specifically. So then again, I will repeat, please listen to the explanation. Alright? Very important. So now, first things first, always remember what's the order you should get. So if you want, you can actually tell me fast enough. If it's 2 by 2 and 2 by 2, very good thing, very fast. You are going to get a 2 by 2 matrix. Perfect over there. Second thing, once you know the order, write it down. So the final order you're going to get is 2 by 2. So 2, 5, 4, 1, 2, 0, 3, 1. Now over here, what happens? Okay, your order of how you multiply or the way you multiply things, again, if the order increases, you might get a little bit confused. So very, very important to know when you multiply, where is that particular exact entry gonna be? So let's say, first row, again, I'm gonna repeat this quite a few times. You may find me a bit naggy, but bear with it, this is gonna do you good. First row, first column. It's gonna be at the first row, first column of the particular matrix, which is over here. So when I multiply, it's going to be, if you want to write down the working with me, 2 by 2 plus 5 by 3. It's going to be long. Okay, next up, if you follow the same thing, color code again, yellow with blue. Yellow with blue, what are you going to get? Yellow with blue, you are going to get, I think my handwriting will extend. Let me write it out first. You're going to get 2 by 0 plus 5 by 1. 5 times 1, sorry, not 5 by 1. Okay, third one, following the order, you're going to have 4 by 2 plus 1 times 3. And last one, let's give it a try. What will be the operation over here? I'll give you a while to write it out. What will be the operation over there? What should be the operation that I should write at the entry over here? I'll give you some time to write it out. Very good, Sing. Anybody else just wants to try? I'll give you all some time to think about it. Yeah, I'll give you all some time to take a shot. Very good, Denise. Anybody else wants to give it another shot? Give you all some time to write it out. It'll be good to write it out because that way you actually understand how this matrix multiplication comes about. Alright, it will help you all a bit. And in fact, I see you are doing good. So you realize I'm getting, in this case, 4, 0, 1, and 1. Just remember top with top, bottom with bottom in this case. And this is going to give you, in this case, my answer of 19, 5, 11, and 1. Okay, so in this case, just be careful with your multiplications and you will do good. Okay, so now with a work example, I believe you know what's coming up. Bubble question for today. Okay, bubble question 3 related to this. Similar, same order of the matrix, but how we multiply. Okay, take note of the order that you have. In fact, all the order is the same, so you don't have to do it the extra step, but take note how you should multiply. Launching the bubble launcher in 3, 2, 1. Let's go. Alright, doing good. Okay, I will see you guys are doing good already. So always remember, in this case, no need to write the order because the answers will seem obvious on what is the order. But take note on how we matrix multiply over here. Alright, give me some time. I'll give you some time to write it down. one more minute. All right, so take some time to understand what is the answer that you will get with the options there. Very good, perfect over here. So take note, don't mess up the ordering. It's top with top, bottom with bottom. There's the hint down here to get the actual answer. Right, last 40 seconds. Alright, with that, let me just digress a little bit. Along the way, I understand this is the last year of your secondary school education, but please take short breaks in between. Do not stress yourselves out. And ultimately, if you have any questions to ask, we have the very nice teachers in the Genie Ask to help you out. So you can approach them, or if you have any questions related to this lesson, in priority first. You can ask me during the Q&A, or if let's say there's no questions with regards to these lessons, but other lessons as well, you can ask me ahead. Okay, last 5 seconds. Okay, let's take a look. Now, most of y'all got it right, but I think some of y'all may have messed up the multiplication a little bit. So for those who got it right, good job over here. But those who did not, again, listen up. Don't worry, I'll be here to help you. But you must listen to my explanation. Over here, all right? So, let's go. Now, again, I want my first row, first column matrix. First row, first column of my new matrix. So always remember to know, okay, I want my first row, first column. And this will mean, okay, top with top plus bottom with bottom. Following the same thing over here, what will I get for the next one? If I color code, let me just color code for the rest so that it's easier for me to use the colors. So next one, I want the first row, second column. So it's going to be multiplying the yellows with reds. So it's going to be 1, 0, 1, and 2. Following further down, second row, first column. It's going to be 2, 3, 4, and minus 1. And last one, okay, don't have to tell me the stats, but can you tell me which two colors should I consider when I do for the last entry? Which two colors over here should I consider when I do my last entry? Okay, to consolidate, which are the two colors I should consider? All right, very good, Ling. Okay, yep, very good, Denise. In fact, it's the blue and red, simish pink, depending on the screen you are reading. Okay, and in fact, this will actually be 2, 0 plus 4, 2. Simplifying this further, you are going to have 3 minus 1, 2, 0 plus 2, which is 2, 6 minus 4, which is 2, and 0 plus 8, which is 8. 2, 2, 2, 8. That's where you have your answers at number 2. A lot of 2 here. Huh? Okay, so that is where you have answered marble question 3. And in fact, this is what happens if you multiply matrices. Just take note. If you have the first row, first column, and any other positions of this new matrix over here, just take note what is the particular row, what is the particular column that you need to multiply them throughout. All right. Now, what is then another variation of questions that they can sort of combine these particular concepts together to bring you to a seemingly hard question? Okay. Well, let's go on to it and let's see what we have. But of course, you realize there are some recaps that we have yet to do. In fact, when we went through the lesson overview just now, so let's see what we have over here. So equal matrices. Now let's recap. If we want two matrices to be equal, first things first, this word over here, what is this word I should fill in? They must have a same particular thing. What is the same thing I am looking at? What's that particular keyword? For those who want to try, write it out, think about it. They must have the same something. That's right. Anybody else wants to try? What is that particular word I'm looking out for when I actually write it up? Okay. The keyword here, yep, as Ziying have mentioned, is actually order. In this case, the same size. and the elements have to be the same. So that means over here, if A and B are equal, can anybody tell me what equations can I form over here? Or in fact, just tell me one equation that I can form over here. If A and B are equal, what is an equation? Give me just one equation over here that I can form. If A is equals to B. Anybody want to try? In fact, if I were to color code it here, it will be clearer. And D, if they are equal, and if you follow the notions over here, okay, I'm seeing certain answers here. Very good. Perfect. Okay, so you realize I have A is equals to W, B is equals to X, C is equals to Y, and D is equals to Z. So this is the notion of equals matrix. Perfect over here, saying there's one equation I'm looking for. Good job. All right. Now, following up, let's again. If I were to add and subtract them, again, the keyword is they have to have the same order. If they are different size, this follows very similar to multiplication. You don't have enough elements to add them up. And in this case, the order do not change when you add them. So therefore, in this case, suppose A plus B. Again, we add them according to their positions. If I were to color code them again. So do some color coding. Okay, again, B, C, D. Okay, if I were to do the color coding, you realize A plus B, I'm going to get exactly A plus W. The other one, B plus X, C plus Y, D plus Z accordingly. Very good. Take note, Zing, over here, I'm not doing matrix multiplication. I'm just adding them. What you are telling me is the matrix multiplication, Zing. So take note. I'm just adding them. So don't get confused. So just be careful, okay? Now, next one, if I were to subtract, come, let's redeem ourselves. What would be the first entry here if I were to subtract? What will I get over here? And for the rest, give it a try. Very good, Zing. Anybody else wants to try? For the rest, who wants a recap over here? Very good. Following up nicely. You realize first one, I think you guys got it ready. I'm going to have A minus W, B minus X, perfect, C minus Y, and D minus Z. Perfectly answered by C over here. Perfect. Awesome job. Now, last one over here, let's have a last recap. Scalar multiplication. When we do scalar multiplication, it's much more straightforward, but please do not get confused with the matrix multiplication we are doing today. Scalar multiplication over here, when we talk about this, it's just a particular number. That is not matrix. It's not matrix form here. It's just a number. So think about 3 times. So suppose K is 3. I'm talking about 3 times the matrix. So in this case, what we do, if I have a one number, every particular element over here in this matrix is just multiplied by K. For example, if I have A in this matrix over here, K of A will be just each of the entries getting multiplied. That's right, it's in every element. That's correct. So KA, KB, KC, and KD over here. That's right, perfect over here. Perfect, perfect. Doing so well. Doing so well. In fact, you are doing an awesome job over here. Right, keep it up over here. You're doing awesome. Now, what happens? What such questions can come about when we combine everything? This may seem very scary, but calm down. Calm down, horses. Yes, it seems very scary, but again, let's follow what we have. If they are equal, definitely we have to see what's the order that we get. So step by step, we are combining everything together. So from here, I'll go through a bit slowly. First steps first. The one on the left seems very scary. But again, let's take a deep breath, breathe in, breathe out. And again, if you were to follow my explanation, you will get it. Right, so let's see how we tackle this particular concept. Now, matrix multiplication. Always remember, first thing to take note, write down the order that we have. Not one, sorry. It's going to be 2 by 3 and 3 by 1. So what is the order of the matrix that we'll get on the left-hand side? What's the order of the matrix that we'll get on the left-hand side? Very good, Ziying. Anybody else wants to try? What's the order of the matrix? Very important over here. What's the particular order? Very good, Denise. Anybody else still wants to give it a shot? Okay. So for those who have answered, all right, perfect over here. You realize what we do? All right, nice. I have more responses over here. I cannot catch up already. So realize I'm gonna have 2 by 1. And in fact, following the notion, row and column. This way, you realize these two are the same. So this tells me, okay, I'm gonna get a 2 by 1. And let's get on towards multiplying. So in this case, my order, the matrix I have will be very different here already. So can anybody tell me what will be the first row, first column? What is the working I should have based on the highlighting over here? Okay, I've highlighted already. In fact, I'm going to confuse you with more colors. So tell me what is the step or what is the working I should write over here. Yeah, I'll give you some time to think about it. What is the working? Yellow and green, perfect color combination. And in fact, if we were to write, very good thing, if we were to write down the workings over here, let me just take a sip of water. If you were to actually follow up nicely, yellow and green add together, very good, Denise. And take note, top with top, the middle with the middle, and the bottom with the bottom. Very good, Denise. In fact, I think there's a little error over here. It shouldn't be a plus. It should just be multiply, -1 and -2. But I think it's a typo at your side, so don't worry. I got it. And let me just see what I should do. All right, over here. So -1 times -2. Just take note, it should multiply this way. And the next one, only 2 colors left. It's going to be red and green. That's right, or in this case, pink and green, or depending, it's red or pink. I'm not too sure why this is pink, but maybe depending on your color, your screen might be a bit bright. And the way we multiply is going to be 0 and 3 plus 5 and 1 plus y and minus 2. Y and minus 2. Okay, now first thing done. Now let's see what we can do on the second side. Second side over here, you realize it's going to be our scalar multiplication. So again, bring the numbers in. First one you're going to get, I hope you all got it, 3 and -9. Minus what is the particular matrix you're going to get? It's doing very good first one. Let's try the second one. What is the particular matrix you're going to get here? Very good. You're going to get 8 and minus 12. That's right. You're going to get 8 and minus 12. So from here, you are going to have 8 and minus 12. Okay, I believe you multiply the -2 in, okay, but in this case, I don't do the, wait, let me just take a look. In this case, yes, you can multiply the -2 in, but for this particular working, I will not multiply the -2 in, but it's okay. It's still fine in terms if you were to multiply the minus in. But if I don't multiply the minus in, I'm going to get -8 and 12. It's the same thing over here, so don't worry about it, okay? It's either you write this, or you can write as 3, 9 plus 8 and minus 2. Okay, essentially, you are going to get back the same working. Alright, so don't worry about it. Okay? Now, from here, we evaluate the entries. Left-hand side is going to be 6 plus x plus 2 equals to 5 minus 2y. This is equals to, again, evaluate further. Ultimately, when the question seems complex, you realize, hey, it's actually not so scary after all. If we were to simplify a little bit more further, always remember when you see a question, when the working seems tough, write up what you have. So you realize 8 plus x equals 5 minus 2y. Yes, I agree it's very tedious, but ultimately, this kind of question should consist of quite some high marks. So don't worry about it. 11 equals to -21. More tedious, more marks. So show all the steps and you will be good. Okay, now, what can we derive from here? What can we do from here? You realize since they are equal, what can I say? Write down your responses. Let me just see what you have. What can I say from these two equations? Very good, Denise. Anybody else wants to try? Very good. Following up very nicely. That's the answer for the first one. And Denise, following up very nicely for the second equation. And anybody else wants to try? You don't have to give me the answer. Don't worry about it. Any equations over here that you can type. So take note, because firstly, it fulfills equality. Order are the same. And since they are equal, the equations have to be the form like this. Not have to be the form like this. So it have to be formed in this manner. So that's where you have x is equals to 3n. It's not or, because it fulfills both. And Denise with Ziying following up nicely. Denise following up nicely with this equation. Solving it is going to be negative 2y. Very good. That's the answer. Minus 26 dividing by minus 2y is equal to 30. Perfect over here. Okay, so this is one particular way whereby a question can seem a little bit tedious here. And of course, because it's tedious, let's try it out over here. Again, it seems complicated, but breathe in, breathe out. I'm going to give you all a 30-second head start. You all can start ahead first. I will launch the bubble launcher in the next 30 seconds. So try working first. I will launch it in the next 30 seconds. It's 2 minutes long, but I feel it might not be enough, so I'm giving you extra 30 seconds. We started about 15 seconds ago. So give me some time before I launch the bubble launcher. Okay, I'll give you all about 10 more seconds before I launch the bubble launcher. Okay, in fact, this is a little bit harder, so give it a shot. Okay, I'm going to launch it in the next 5, 4, 3, 2, 1. Let's go. Alright, so take note when you have such a question, what is the first thing you should do? Okay, remember when it's matrix multiplication involved, even though it makes sense on the right, good to double check what is the order of the final matrix that you get when you do your matrix multiplication. Very important. Yeah, I'm seeing some answers coming in. Alright, you have about 1 minute and 20 seconds left. You got some time. What happened, Ziying? What happened? Did you write the wrong voting or did your fingers slip? Okay, just be careful, especially with the interface. Okay, you guys are doing good. You guys are doing great. Just make sure that when you answer these questions, remember, don't think too hard. Always remember to think. Okay? Always remember to think it in that manner. Alright? Last 15 seconds. Let's give it a shot. Okay, for those who are still manipulating, you have about 40 seconds left. Last 30 seconds left. Yes, this question is a little bit tedious. Last 20. Last 10. Right, so I'll go through this. I think because it is tedious. Last 5, let's give it a shot. 2, 1. Okay, so seems like you realize this is a little bit tedious, and take note therefore the manipulation of the working, you have to be very careful. So be very careful and make sure to listen to my explanation over here. Alright guys? Okay, let's go. Okay, so what happens? Now, always remember on my left hand side of the particular matrix, what do I do? It's always going to be row. It's going to be always row by column. And take note what's the order that we get. We are going to get first one 2 by 2, second one 2 by 2. So final order you're going to get is 2 by 2. Okay, now when you matrix multiply, okay, I'm not going to elaborate and ask, but I hope you guys understand. First row, first column, b times 0 plus negative 2 times 2. That's the first part. Second part, you are going to get Okay, I hope you guys got it. It's going to be Pn minus 1 plus negative 2 times 0. Third one is going to be negative 16 times 0 plus 0 times 2. Fourth one is going to be negative 16 times negative 1 plus 0 times 0. Now following up next, you realize next one is a little bit tedious. First, we need to scalar multiply. So we settle for the first one, which is 4 minus 4b, 10, negative 3, negative 6 and 12. And then we do the adding of such to a, negative 7, 6, and 4. Okay, don't hurry to solve first. Try to evaluate and simplify. Do not leave your working like this. Simplify further. You realize I'm going to get negative 4, negative, in this case, b. The other side I'm going to get 0, 0, and lastly, 16. What is this equals to? We add them on the right hand side. It's where we have 4 minus 4b plus 2a. It's going to be other side 10 minus 7, 3, minus 6 plus 6, 0, and in this case 12 plus 4, 16. Simplify a little bit more, make it easier for your side. Okay? Or in fact, we don't really have to simplify more, okay, because that's what we have over here. Now let's take a look. What are the equations we can work with? Because we want to solve for, take note, we are solving for A and B. So what are the equations I can form? Take note A and B. So realize, oh, there is A here. This is this. Because they are equal and B is here. So realize immediately when we have these two equations, A and B, what's the first equation we take note of? The red color one, which is negative B is equals to 3, B is equals to minus 3. Take note of the most simple one. That's right, Ziying. Minus 3. Okay? It's not 3, it's minus 3. Okay, I think that's where it went wrong. So some of y'all chose the wrong option. But take note, it's minus 3 because minus B is equals to 3. So we divide by minus 1. Okay, no worries about it. But yeah, you got it. Now next up, what happens? From there, we try to see whether we can solve for the green color one. And in fact, if we manipulate, 4 minus 4b plus 2a is equals to minus 4. So 4 minus 4 of minus 3, because b is minus 3, we can sub it in, plus 2a is equals to minus 4. So evaluate further, 4 minus or 4 plus 12, 2a is equals to minus 4. And in this case, simplify further, I'm going to have 2a plus 16 is equals to minus 4. Simplify again, 2a is equals to minus 20, a is equals to minus 10. And therefore, your answer is both minus, so number 4. So take note, these kind of questions you combine a lot of concepts, and the main thing is the matrix multiplication. Just be very careful with the matrix multiplication. Alright guys, okay, so with this, that's actually all for today. So what have we learned? We have actually learned and more or less recap everything over here. But the main concept is how we matrix. Alright, so that's actually all for today. Thank you for having your time with me, and I hope this lesson is clear. If there's any questions ahead, there will be a short Q&A. Otherwise, I'll see you all next week. Same time, take care. But then I'll see you again. Right, take care. Bye-bye.